Hey everybody, welcome to this retake discussion on the CER that we just took. So you were asked to write a CER, and if you're listening to this video, the CER didn't quite go as good as you had hoped it would go. So you're going to retake the CER, and this video or this series of videos will help you with the retake. So you saw that there is a clock placed on top of a table and it's not moving. So the question is, why is the clock not moving? So that's what you would write. That's what you would answer in your claim. Why is the clock not moving? Now, before you write a claim, make sure you go through all the information and the data. For example, it said that below here, now I did move the interaction table up, that's why it's not below anymore, but you had an interaction table, a force model, and a free body diagram. Make sure you look these over to help you write your claim, because you don't want to write a claim and then find out there's absolutely no evidence to support your claim. So you want to look this over as well. And you also want to begin to look over your scientific principles. And this will help you, hopefully, create an argument that will support your claim in your scientific reasoning. So we're going to actually start with the evidence portion of a CER, because you never really want to write your claim first. So evidence that should be sufficient. You have to have enough evidence to support your claim. It's got to be appropriate. You're going to use data that supports your claim. Leave out information that doesn't support the claim. And then include qualitative and quantitative information. Quantitative is numbers whenever possible. And this one, you're not going to really have any numbers. It's going to be more qualitative. So let's look at the data. Let's look at the information. Now you have an interaction table, a force model, and a free body diagram. So as you start to look at it, one, you're going to have to understand what these are. This is part of what I'm testing you on. So why is the clock not moving? Now, in order to have movement, you have to have forces acting on an object. And you can see from the interaction table, the clock has two things interacting with it. The table, and you can see those forces right here, and gravity. Now, remember, the free body diagram is only, it's simpler than the force model. It only shows the things that act on an object. So the only two things that act on the clock is the table pushing up on the clock and the weight pushing or pulling down on the clock. Both of these forces are vertical. The dashed line means it acts at a distance. The solid line means it's a contact force. Now, ultimately, that doesn't matter. What you do notice is that both of these are equal in size. So that means they're balanced. That's huge. So you're going to want to talk about that in your evidence, that the force of the table on the clock is balanced, and it's balanced with the force of the weight on the clock. So a good statement might be that according to the free body diagram, the vertical force of the table pushing up on the clock is the same as the vertical non-contact force of the weight pulling down on the clock. So you could have a statement similar to that, or very similar to that. You should have one. Now, do we need to talk about how Earth is pulling on the table and the table is pulling on it? No, that has nothing to do with why the clock is not moving. But there's also one very important detail that you see here in your evidence. Where don't you see arrows? So if we know that that clock is not going to move up and down because the table is pushing up with the same amount of force that the Earth is pulling down, but why is it moving sideways? Well, again, if you look at the evidence, you also want to include the fact that according to the free body diagram, there are no horizontal forces acting on the clock. So this is all you want to have in your evidence. You just want to have, well, the evidence. Don't include scientific principles. Don't explain why that matters. That's going to happen in the reasoning. So again, you're going to want to talk about how the vertical push force of the table is balanced with the vertical pull force of the weight. And because those are balanced, we're going to get into the reasoning part of it and explain why that's important.